Hello. Okay, so let's start and let's start with okay. So we have solved A, B, C, F, G, H, I, J, K, L, N. Okay, so M is not solved. Okay, and then we have the matching questions. Okay, so M candies. Okay. So I think I discussed a little bit on this question yesterday. So we are given n childrens, right? And each of these children have capacity to them, right? So we have n children, and we have the capacity of children, right? How many candies they can have, right? So we can write as candy capacity. And then we have k candies to share. Okay, we have k candies to share. So the question is, how many ways we can share k candies between these children, satisfying their this condition that the candy they received should not be should not exceed the capacity, right? And they can receive 0 to AI candies, that is inclusive. So if we did not have this, right, this condition, then it would be a simple uh, target sum type problem, right? Then it would be a simple target sum type problem. But now that we have this condition, we will have to also include this into our solution loop. Basically another loop will be there now. So let's see how the recursive solution could be done. So we have a function, let's say we have dp, and this dp actually has two states, right? I and the amount of candies we have. Okay, so think about it. If we have I students, I childrens, and we have k candies, so what will happen if we have 0 candies? In that case, if we don't have any candies, in that case there is one way to do that, right? Because every every child can receive 0 candy, so that is one way. And if we have candies, some candies, but we don't have any children, then in that case number of ways to distribute those candies will be 0, right? Because there are no children, so there's no way. Okay, so these two will be our base cases, right? Then what about the main thing, distributing the candies? So for that we can run a loop, right? For j going from our j will go from 0 to ai, basically that particular child's capacity, right? And then we will just add the different ways of distributing the candies. Basically our DP, what this DP gives us is number of ways k candies can be distributed. Shared among I children, and obviously under this condition. So then we will just add this, right? We have given the ith child j candies, right? So what is the remaining candy? It will be k minus j. So we are adding this to our answer, and finally we are returning the answer. So this is how the recursive solution would look like. But what is the time complexity for this? If we see, this thing itself can go from k 0 to k. So basically a big O of k, right? And then we have this dp where I can go from 0 to n, so we have a big O of n complexity, and k can go from 0 to k, so we have a big O of k complexity. So combining all this, the time complexity for the recursive solution will be big O of n into k into k. So we don't have the memory or time to solve this question efficiently, right? So again, and if you try to do it bottom up, then also it will be the same, because there also you will have 3 loops, one to run from I for running the I, one for k, and another one for j. Okay, but if you see, what are we doing actually? Here you will not be able to you might not be able to say this in first try. I also was not able to. So here what we are doing is, we are adding the dp states from 0 to ai, right? We are adding the dp states from 0 to ai, so it is kind of like a prefix sum. Okay, so if somehow we can get rid of this loop, right? If we can get rid of this loop, then our problem will be solved, right? We won't have this additional complexity then. So our main objective will be to remove this and convert it into a prefix sum type of thing. So for that, let's take a example here. Okay, this is the example. Okay, so see, we have a 2D DP, right? We have a 2D DP here, where I will go from 1 to n, or 0 to n minus 1, or k will also go from 0 to k minus 1, or 1 to k, or 0 to k. Okay, so I'm taking 0. So we have 0 here, and we'll go from 1, 2, 3 and 4. 1, 2, 3 and 4. Okay. No, sorry. Another 0. 1, 2, 3. 1, 2, 3, 4. Alright. So if we have k0, then it will be 1. Okay, so it will be 1. So all this will be 1 and all this will be 0. That much we can see. Okay, and then here what will be the DP tree? What will DP tree will look like, right? What will the DP tree look like? So we have a DP n and k. We will go to DP 2 0. We will go to DP 2 1. We will go to DP 2 2, or we will go to DP 2 3, or we will go to DP 2 4. So we have all this different possibilities, right? And from here we can see that we will be returned 1. This we will again solve it. Okay, we will again solve it. So 2 0 is 0. So okay, DP1 again we will go from we'll go to DP1 0, and then DP1 1. Okay, and this will again be written as 1, right? And this thing we will again go to DP 0 0, or we can go DP 0 1. This thing will return 0. Here we will return 1. Okay, so overall we will return 1 here. Similarly, for DP2 2, we will go DP1 and 0. We have already solved it, and we will go DP1 1. We have already solved it, and we will go DP1 2. This we have not solved it. So DP1 0 and 1 1 will give me 1 and 1. No, because this gave me 1. Wait. 0 0 1 0 1, so it will be 2. Okay, no, it will be, this is I j 0, so okay, this is 1, this is 0, and this is 0, so it will return 1. Okay, so 1 we also have, so it will 1, so it will be 2. Okay, and similarly okay, but we also need to check, right, that the person receiving the candy should not get candies that exceed their capacity. So we haven't checked it, so some of the branch will be like pruned. Okay, so anyway, I just wanted to fill this table. So here for 1 1, since he can receive 1, so this thing is possible, it will give 1. Okay, 1 0 is already done. Okay, 2 1, 2 1 is also possible. 2 3 is not possible, so we will not even solve it. No, 2 3 is possible, so 2 3 is possible. 2 3 is possible if we give him 2 candies first and then him 1 candy. So we will have to do this also, solve this, but here for 2 2, or basically for 1 2, let's see for 1 2, and we have 1 2. Okay, we need to solve here. Okay, for 1 2, again we can solve dp 0 0, dp 0 1, or dp 0 2. Okay, so there is no way of giving him like any candy, so it will be 0. So the only way 2 toffees, 2 candies can be distributed till here is if you give this guy all the candies, or you give this guy 1 candy. So both the cases we get 2, so it will return 2, yeah, as expected. So dp 1 2 will be 0. Okay, dp 2 2 is 2. Okay, and dp 1 3, what about dp 1 3? Also we will have to solve here. So dp 1 0, dp 1 1, dp 1 2, I hope I'm not muted. Okay, dp 1 2, and we have dp 1 3. So again, dp 1 0, it will be 1, dp 1 1 is also 1, dp 1 2 is 0, dp 1 3, again we'll see, dp 0 0, we have dp 0 1. We have no way of basically sharing 3 candies to 1, because he cannot have 3 candies, and also if we are remaining with we have like remaining candies, and also it will not be accepted. So this will be 0. So anyway, I'll just write it. And for similarly for 4 also, it will be 4 0, and that we can do from here. Okay, so but for this I'll just do it, dp 0 2, dp 0 3, and all of them will return 0. So it will return 0 and this will return 2. Okay, this will return 2. And for dp24 we have dp 10, we have dp 11, we have dp 12, we have dp 13, we have dp 14. Okay, so okay, we know this is not possible, this will give 0, this is also 0, this is also 0. This is possible, so it is 1 1 because we solved it, it gives 1. For 1 0, this is 1 also. So there are two possibilities overall, so it will return 2. So now we see we have 9 as the answer. And what is the answer? Answer is 5. Why? Of course, we need to check if J is less than capacity. But we already checked it. Okay, so this case we cannot have, right? Because 4 candy to third guy is not possible, so we will not do it. This case is proven. Okay, again, some of the cases here are still not checking the condition probably. Here also, if we give okay, so here it means we have given the third guy 3 candies, so it is possible. Here we have given 2 candies, here we have given 1 candy, and here we have given 0 candies. So all of these 4 possibilities are there. For this we have okay, so this is also legit. For 2 2, this will not work. Okay, so this will work and this will work. Okay, for 2 3, this is 0. This is not correct, so it will return 1 only. Why is it not correct? Because we are giving the second child all the 3 candies, which is not possible. Okay, so this is not correct. So we have 2 2 1, and what about 2 4? 2 4 is also, I don't think it is possible, because in all the cases we cannot do this. This is not correct, this is also not correct. Well, this may be correct, but again we cannot, we will have remaining candies, right? So this is not correct, this is not correct, this is not correct. So all of this thing will give us me 0. So again, so answer will be 5, not 9. Yeah, so my mistake, we didn't prune the branches properly. So you can see, let me fill the DP table here. We have 2 1 as 1, no sorry, we have 2 1 as 2, we have 2 3 as 1, we have 2 4 as 0, we have 3 1 3 1 3 1 3 1 3 1. There is no 3 1 state. Okay, so there is no 3 1 state. 3 2 3 4, no, there is no nothing. So 0 0 0, last 3 4 is 5. So you can see that let's start from here. 1 1, right? 1 1 is actually the sum of this guy, right? 2 2 is or basically 2 3, or let's say this guy 2 is actually the sum till this guy. Okay, also here this guy also is the sum of this guy. Okay, or maybe let me try to explain it in some other way. So you see, when we are doing the, what are we basically doing in the function? We are doing this, right? Ij is equal to dpij plus dp I minus 1 j minus k, or let's not do it, we'll do k minus j. Okay, so you see what are we doing basically, and this will go for all j equal to 0 to ai, right? So basically if our k is this, then whatever capacity we have of the current children, for example this child, whatever capacity he has, so till that we are adding the dp values, right? So for example for 2 3 we are going dp I minus 1, so here, okay, so I minus 1 throw, then k minus j, such that j goes from 0 to ai. So our ai is 2, so it can go from 3 to 1, right? So in this area, what is the sum of our dp? It is 1, so that is why it is 1, right? Similarly for 2, we can go from 2 to 0 because capacity is 2, this guy, right? So what is the sum? Sum is this entire thing, so this is it. Similarly for him, sum is basically this. So we have the sum we have the dp state defined, right? So answer is what? 4 and 3, last 3 states, so it will be like this, and that is how the answer is coming out to be 5. So if I am able to explain it, I think we can I hope that I am able to explain it, and like you get how the dp is dependent on the previous state sum, right? So what we need to do is we need to get rid of this loop. Where is it? We need to get rid of this loop. Okay, so what we can do is have a prefix array as well. Okay, and that prefix array will store all the sum, right? That prefix array will store all the sum. Okay, again, what will happen if the capacity exceeds, let's say the capacity, what will happen if we have a children whose capacity is less than k, for example. What will happen if the capacity is less than k? In that case, we will not be able to go from this to this. In between, the children will be like, yeah, he will not be able to. Okay, so we will have some toffees or candies remaining, right? So we will not be adding all these numbers. We will be adding some part of it, like in this example, right? We added 3 numbers, but we did not include 0th position here. So we added these 3. So similarly, when capacity is k, for prefix sum we will add the I minus 1th from this position and j to our I minus 1th position to j minus our capacity minus 1. So this is how prefix sum works, right? If you have an array and if you want to get the sum of particular sub array, then what you do is you create an array where the next element where the current element adds itself and the last element, right? So here we have 0, will start with 0, current element will add 0 and itself, then we have 2 and 1, it will be 3 and 3 is 6, and it will be 10 and it will be 15. So if you want to calculate the sum of this subarray particularly, so we'll do 10 minus what is the length of the array, or what is the if you are talking in index, then what is the I minus 1th sum in prefix. So it will be 1, right? This guy and this guy. Because we don't want to include this guy, we will exclude this from the sum and include till here, right? So it will be 9, and if you check it, it will be 9. So yeah, so you do j minus I minus 1. Okay, this is the concept for getting sum from I to j. So we will do here like that. So if capacity is k, this is our TP, okay, the sum. And if capacity is greater than equal to k, then what? Then in that case TP is nothing but I minus 1 j. Because in that case we can go up to 0, right? So I guess this is it then. Okay, so let us implement the solution for this. So we will have a prefix array, and before that an array for storing the capacities. Okay, we will have a prefix sum, and since it is a 2D prefix sum, we will take n plus 1 and k plus 1 dimension, all initially 0. Okay, and similarly we will have a dp with the same dimension initialized to 0 only. Okay, for the base case we have this. Oh no, not this one. We have this. Where is it? K0 1 I0 0. Okay, so okay, we have the base case done. We'll run the loop. We can start from 0, but we'll start from 1 because there is no need, and I will go from go till n. Here I will go till k, and we'll check if our okay, one more thing, I don't want to do this, so I'll do this. Okay, cf1n scene cf I1 as scene I. Yes, that will work. Okay, again here also. Okay, I have this macro in my template, but I've never actually used it, so it kind of feels weird. Feels kind of weird to use this. Okay, so if we have the capacity, if we don't have the capacity to take the candy, or yeah, in that case the dp will be I minus 1 j minus I minus 1 j minus ai, or just say c. C and minus 1 because it is a prefix, and also we need to mod it, but yeah, we need to mod it, else the dp is the sum of the previous row till jth element. Okay, and after that we will need to update the prefix sum as well, because we are adding simultaneously, right? So it will be prefix I minus 1 sorry prefix I j minus 1 plus dp ij, and okay, I'll do mod here also, and then we'll just see out dp and k, and that should solve the problem. That 0. Okay, so this is working. Okay, and let's see the see the dp. So okay, and what about the prefix? Oh, prefix is all 0. Let's just set the first row of the DPS 1. First row as 1, so dp 0i. Okay, What is the problem? Okay, sorry. Okay, we don't need this, we'll do this. And now let's see. Okay, getting minus, that's all it. What is the sum? That is also minus. Okay, why? Okay, this is wrong. now we have a working code. Okay, so I forgot to actually include the DP state in the prefix. So you know how we set the initial elements of prefix array. I forgot to do it, and that is why I was getting the wrong answer. And let's check the other test cases and see if we are correct or not. Okay, one correct. This should be one okay. What about this one? We are correct. And yep, copy, and we'll paste it, verify ourselves, and submit it, and see if we get any TLE, MLE, or wrong answer. I think we'll get some MLE or wrong answer. Yep. That's because of the mod, I think. Yep. We are getting 2 test cases failed, and that is mostly, I think, because of this. So what happens is, since we are subtracting, right, it may happen that this guy is less than this. Okay, so in that case we'll just add a mod that will even it out. Okay, this is a trick I learned during my ICPC days, I think. Yeah. What was the question, Candice? I hope it works. Submit. I don't think we should get any TLE, MLE, or wrong answers. Okay, so we have all the questions solved till M. Okay, sorry, N. Now let's go to the matching question. There are N men and N women, both numbered 1 to N. For each ij, the compatibility of man is given as integer 0, 1 if they are compatible, 0 if not. Taro is trying to make N pairs, each consisting from man and woman compatible. Here, each man and woman must belong to exactly 1 pair. Find the number of ways in which Taro can make N pairs modulo 10 to the power 9 plus 7. Okay. Okay, the thing is, we have a hint here, right? We have a hint here, and that hint is N is less than equal to 21, and whenever that is the case, the question is surely going to use bit masking. Okay, because they love it. They love the bit masking. I'm not sure how I'm going to solve this. The thing is, okay, we have, okay. So every row here is basically the compatibility of a man with all the women, right? So suppose if we run a loop, space. Okay, we are at O. We are at O, and what is it? It is matching. Okay, so we are given basically this test case. Okay, so we have this test case where n tells us the number of men and women, and this is the women side and this is men. Okay, so if it is 0, that means 1 and 1 are not compatible. If it means 1, then means 1 and 2 are compatible. Similarly all, right? So how do we process this? Let's say this is, let's convert it into a number. Okay, so what will it be? It will be a what, 1 plus 2, it will be 3, and this will be what, 4, 1, 5, this will be what, 7. So we have 3 numbers, but it is basically a list. Okay, in that list again we have to check, we have to somehow use dp to get the answer. What are the number of ways in which we can choose to make all the pairs? Okay, so what happens when we choose a pair? Okay, so for the first male we have number 3, so basically 0, 1, 1, and this is first female, second and third. If they are compatible, since she is not, we will not consider her. If they are compatible, for example 2 and 3, so in that case we will choose them, right? In that case we will choose them, but thing is, for the next male we will not be able to choose her then, so we will have to flip this bit. So for the next person the considerations will be 0, 0, 1, and whatever are her whatever are his what do you say, compatibilities. Okay, so this number from the last and the current number, so this will be odd, not or, it will be yes, it will be odd, but we don't want this to be included, right? So in that case what do we do? If we do XOR, in that case this will be 1, this will be 0, and this will be 0, so we don't want that. We don't want that. We can that is the thing. If we have already chosen this, already chosen her, then we cannot have a pair with her again, right? So we'll need to do an operation that will how do I change the for the next guy, like guys thing, because I'm muted. Sorry. Ah. Okay, so this is the solution that we uh, that I've understood, and yeah. So what I'm trying to do right now is to be able to solve and remember patterns, right? And I for that I actually looked at different blocks and how to solve it, and saw that I was going off the way. I was like not even close to solving it. So this is the standard way, I think, and I had a hunch that they will use something like this, but still. So this is the solution, and we'll implement it. Okay. From tomorrow, I'll try not to mute myself. Actually, there are some you can say noise elements here, and that is why sometimes mute my mic and forget to unmute it. So sorry. Okay. So we'll take the input, and we have the matrix, right? So our matrix will be just a simple matrix. So just a simple matrix. What was compatibility? Size n, and again size n, and we have for. Now we have f going from start is 0, end is n. Again we have f going from 0, j0 n, I'm trying to use the template here. Okay, and C in com ij. Okay, so this is array input, and now we have the dp. Okay, so we will have the dp like this. What is the size n, and again the size is n0. Done. We can have a max, which is this. We'll run the loop from I to n, and in that we'll run a mask from 0 to mask less than equal to mx, and mask plus plus, and if the built-in pop count of the mask is double equal to I, in that case only we will do what? We'll check another condition. We'll check no, first we'll run another loop for k is equal to 0, k less than k plus plus. We'll check if j, what is the mask and k mask and k, and so we'll check that mask and so this woman is present in the mask, and also that they are compatible. So compatibility of this guy and this woman. Compatibility of this guy and this woman. So this woman is this. The woman is K. Okay. In that case only, we will do dpi mask plus equal to dpi minus 1 mask XOR 1k and mod all of it. In the end, the answer will be in n minus 1 n minus 1 think. I'm sure I'm going to get a segment fault. Yes, segmentation fault. Let's not go till n, so it is 0. Yeah, I need to solve it again. I don't think I've understood the thought process behind it, and also the solution. It goes over my head. Not entirely, but implementation. You can see that I'm looking at the code again and again, because a lot of the so there are some things that you can miss, which can fuck up your entire solution. So bit masking, I need to practice a lot of questions on this. So as we go to, as we we are moving forward with this DP, atcoder DP, we are coming across a lot of hard questions, and we don't have the solution ready for them, so we have to look here and there, right? So yeah, I hope that when I revisit these problems, I don't have to do the same. That is the only thing that and that is the only reason why I'm doing the doing this right now. Even if I look for solutions right now, I don't want it to happen the next time I visit those problems. Okay, but I feel like there will be one or two questions where I need to look at the solutions again. So yeah, that was it for today, and yeah, we started early and we are ending early, and we were only able to solve two problems, one of which was not even solved by me. Both of them actually. So yeah, the prefix problem also I had to look at the solution off camera, but yeah, I learned something new. That counts, right? So yeah, anyway, I hope you will have a very good night, and peace.